بسم الله الرحمن الرحيم.
Assalamu alaikum. Hi friends, welcome to another knowledge sharing video. As you know, network is the backbone of any DCS, SCADA or Siemens PCS7. Mostly there are three network topologies used in plant automation: bus network topology, star network topology, and ring network topology. All three are useful and utilized according to the plant process and safety requirements. Today I will show you basic working principle of ring network and how it fulfills redundancy of plant automation. For explanation, I will use Siemens Scalance X204-2 managed network switch because it has options of RJ45 connectors for short distance communication and fiber optic connectors for long distance communication. Working principle of ring network topology is almost same for all network switches. As the name of ring network, all network switches connect in ring shape. Default ring ports of X204-2 are P5 and P6. These are fiber optic ports. For RJ45, it has P1, P2, P3 and P4 ports. So in first example, we will connect network switches in ring topology by using fiber optic ports. For this purpose, make sure that P5 and P6 are configured as ring ports. You can do this by using configuration software of network switch. For Scalance switches, you can use web-based management. It can be accessed through Windows Explorer. Make sure that you have updated Internet Explorer in your laptop or PC. In the address bar of Windows Explorer, write the IP address of network switch to open web-based management of switch. Use http:// before IP address. First, we have to enter username and password to access to the web-based management. There are two users. One is user and its password is user by default. And second is admin and its password is admin by default. With user login, we can only see the configuration. We cannot change any parameter with user login. Login with admin so we can change the configuration of switch. If you have different network switch, then follow instructions according to your network switch. In top left corner, you can see LED indications which shows the mode of switch, status of different ports and power supply. You can see the RM LED is green, so this switch is redundancy manager. RM represents ring manager or redundancy manager. All LEDs are green and fault LED is off. It shows that switch is working fine. On the right top corner, you can see product name, device type and IP address of device. If you have assigned device name, then in place of IP address, there will be the device name. If you want to learn about Scalance X200 and X400 configuration, then watch my video Siemens Scalance X200-X400 fundamental method of configuration. But in this video, I will try to focus on ring network. So to assign ring ports, expand X204 menu, click on sub menu of ring, check enable ring redundancy. If you want to use this switch as redundancy manager, then in redundancy mode select MRP manager auto/client from drop down list. If you don't want to use it as redundancy manager, then from drop down list select MRP client or automatic redundancy detection. Keep in your mind that redundancy manager should be selected for only one switch in the network, others should be client. If all devices configured with the MRP auto manager auto/client, then switches negotiate among themselves to establish which device adopts the role of MRP manager. The other devices automatically set themselves to MRP client role. Keep in mind, if you configure all network switches as MRP auto manager auto/client, then the device with the lowest MAC address will be always become the MRP manager and all other become MRP client. In other hand, if you configure all devices as automatic redundancy detection, then the switches cannot detect whether or not MRP manager is in the ring. This means that they never adopt the role of MRP client. So for thumb rule, keep at least one network switch as MRP auto manager auto/client Another should be MRP clients or automatic redundancy detection. As per my observation, better to keep other as MRP clients. Click and check Enable Ring Redundancy box. After selecting P5 as first ring port and P6 as second ring port, do not forget to click on Set Values button. Otherwise, any change will not store in switch. Do the same for all other network switches. Now all network switches are configured as component of ring network. To create ring, start from Redundancy Manager switch, connect fiber optic of port 5 of this switch to port 6 of second switch. Then port 5 of second switch to port 6 of third switch, and so on. Keep connecting until you connect port 5 of last switch to port 6 of first switch, which is Redundancy Manager. Make sure that out connector of P5 should connect to in connector of P6 of next switch. Same way, in connector of P5 should connect to out connector of P6 of next switch. If you draw this network, it will create ring shape. That's why it called ring network. After inserting connector in ports, you can see LED will switch on. If all connections are proper among all switches, then you will observe that RM LED on Redundancy Manager switch will lit green constantly. Otherwise, it will start flashing, which could be due to improper connections among the switches, or due to wrong configuration of one or more switches, or due to any one or more faulty switches connected in ring network. Sometimes in ring there is standby ring manager. Color of RM LED of standby ring manager will be yellow. If yellow LED is flashing slowly, it means that standby function of switch activated and the switch is in passive mode. If yellow LED is flashing quickly, it means that standby partner lost. If yellow LED is on, it means that standby function of switch activated and the switch is in active mode. If yellow LED is off, it means that standby function is not activated. In ring network, there is two paths of communication. It means that network switch has ability to communicate with port 5 in one direction and port 6 to other direction. The redundancy manager sends test message on both ring ports. As long as the test messages reach the other ring port, in each case, the redundancy manager does not consider the ring to be defective. Consider server connected with first switch, which is our redundancy manager, and PLC1 connected with the switch 3. If this server wants to communicate with PLC1, then it can use port 5 or port 6 to communicate with PLC1. Currently, it is using port 5 to communicate with PLC1. Due to some wire break or due to any other reason, if test message sent by port 5 unable to receive by port 6 or test message sent by port 6 not received by port 5, then redundancy manager will consider it loss of communication. The redundancy manager will immediately switch to communication path from port 5 to port 6 and it will generate the redundancy alarm. In Siemens terminology, it is called reconfiguration of ring ports. This switching of ports is so fast which will not interrupt the operation of automation system. The ring port changeover or reconfiguration will take maximum 200 milliseconds. In other case, if wire break happened in middle of ring network, then error message will generate by redundancy manager, but communication will remain healthy. You can also create ring network by using RJ45 ports. For this purpose, in web-based management, select RJ45 ports as first and second ring ports. For example, P1 is first ring port and P2 is second ring port, and don't forget to click on Set Values button. Then connect P1 of switch 1 to P2 of switch 2 and P1 of switch 2 connect to P2 of switch 3. Keep continue until you connect P1 of last switch with P2 of switch 1. Working principle will remain same. Sometimes distance between servers and PLCs are too long. In this condition, you can also create ring network by combination of fiber optic port and RJ45 port. For this purpose, select any one fiber optic port as one ring port and any RJ45 as second ring port or vice versa. In this example, you can see switch 1 first ring port is P1, which is connected to P2 port of switch 2. P2 is configured as second ring port of switch 2. Both servers are communicating with each other with RJ45 ports because they are installed near to each other. Whereas PLC or CPU racks installed very far may in local panels on site. So to communicate with servers, it is better to use fiber optic ports. As you can see, switch 1 second port is P6, which is fiber optic port, and switch 2 first port is P5. It is also fiber optic port. Selection of ring ports depends upon distance of network switches and speed requirement. If distance between PLCs and server is long, then it is better to use fiber optic. If distance is short, then usually RJ45 cable has been used. But if in short distance there is requirement of high speed communication, then it is preferred to use fiber optic in place of RJ45. Okay friends, hope you understand basics of ring network and hope it will create base for future understanding. In next video, I will try to discuss ring network implementation in Siemens PCS 7 system, which is same for NEDCS and SCADA. It will be your first step to understand Siemens PCS 7 network configuration. If you like this video, then share to your friends, may it will be helpful for them. See you in next knowledge sharing video. Till that time, Ma salama, Allah Hafiz, bye bye.